Hello students, welcome to Top Scholars. Students, today we are going to discuss about an interesting topic, and that is magnetic field due to a current in a solenoid. Now before going on the topic, the first question is, what is exactly a solenoid? In simple words, you can call it as when an insulated copper wire is wrapped closely in a shape of a cylinder to form n number of turns. For example, here, can you see here? There's a copper wire which is in a form of a cylindrical shape but has a circular turns. This particular section. This particular section is called as a solenoid. Now students, let's see the properties of a solenoid. Now when you'll consider a solenoid, the properties of the magnetic field of a solenoid is very similar to a bar magnet. Now as if you'll remember, a bar magnet has a north pole and a south pole. Exactly in the same manner, a solenoid also has a north pole and a south pole. Okay, so one end is a north pole and the other end behaves as a south pole. Now let's see some more properties of a solenoid. Now when you will consider a solenoid, the magnetic field inside the solenoid is uniform. That is, the magnetic lines are parallel to each other. So as the magnetic lines are parallel to each other, we can say that the magnetic intensity inside a solenoid is uniform. So exactly what does it mean? That the magnetic intensity inside the solenoid is uniform. Okay, and because of that we can call it as a solenoid behaves as a uniform bar magnet. Now students, when you will consider a solenoid, a strong magnetic field is produced inside a solenoid. Okay, inside a solenoid, a strong magnetic field is produced, and this magnetic field can be used to magnetize materials such as a soft iron. Okay, this magnetic field can be used to magnetize a material such as soft iron or another magnetic materials.
To learn more about this topic, download Top Scholars app.